we've done a bunch of examples looking at the actual molecular structure and trying to come up with a name. In this video, we'll go the other way around. We'll start with a name and see if we can actually draw the molecular structure of whatever this might be. So let's start. So when you first look at these, it's very daunting, but you always want to start really at the end so you know what kind of the core of the structure is going to be. So if you look at the end of this, you have an ane, so there's not going to be any double or triple bonds here. It's all single bonds. It's a it's a hexadecane. So let's think about that. Hexadec. So hexadec, that's 6 and 10. Hexadec was a prefix for 16. So this is 16 single bonded carbons, and it's cyclohexadecane. Cyclohexadecane. So 16 single bonded carbons in a ring. So this part of it right here. So let me just do so the cyclohexadecane. Let's draw that part first. It's not easy to draw even a 16 carbon ring. So let's start here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 16. I think I got it. Let me count them again, and then I can connect them up in a cycle. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, I drew the cyclohexadecane part. Now, if we go back a little, let's see, we have a 2,9-diisopropyl. So what does this mean? This means that we have an isopropyl at the 2 and the 9 spot. Now, when you are drawing the structure from the name, you could just arbitrarily, on some ways on this ring, pick what your 1 through your 16 spots are. So I'll just arbitrarily pick them. Because I could have drawn this ring any which way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so this is this next piece right here. Let me do this in magenta. 2,9-diisopropyl. This is telling us that at spots number 2 and at spot number 9, I have isopropyls. The di is just saying I have 2 isopropyls at 2 and 9. So you can kind of ignore the di. So I have an isopropyl, and you may or may not remember that an isopropyl looks like this. It's 3 carbons. So it's going to be 1, 2, 3. And the connection point to the main ring in this case is going to be in the middle carbon. So it kind of forms a Y. All of the isos, the isopropyl, isobutyl, they all look like Ys. So it's going to be linked right over here. It's going to be linked right over there. And that's also going to happen at the 9th carbon. So at the 9th carbon, we're going to have another isopropyl. We're going to have another isopropyl at the 9th carbon. All right, we've taken care of the 2,9 isopropyl. Then we have the 6-ethyl, 6-ethyl, which is just a 2 carbon. Remember, meth is 1, eth is 2, prop is 3. So this is, let me write this down. So this is going to be, so prop is equal to 3. Isoprop is equal to that type of shape right over there. In this case, eth is equal to 2. So it's a 6-ethyl group. So at 6, we have an ethyl group. So 1, 2 carbons. And it's connected at the 6th carbon on the main ring. And then finally, we have a cyclopentyl. Cyclopentyl. So if we look at, let me find a color I haven't used yet. Let's see, I've already used one this here. Cyclopentyl. So pent is 5, but it's 5 in a cycle. So this is a 5-carbon ring that's branching off of the main ring, and it's at the first spot. So let me draw a 5-carbon ring. So pent is equal to 5. So it would look like this. 1, 2, 3, 4, 5. It looks just like a pentagon. That's a cyclopentyl group, and it's attached to the 1 carbon on my cyclohexadecane. So it is attached just like that. And we're done. We've drawn 1-cyclopentyl 6-ethyl-2,9-diisopropyl cyclohexadecane. Let's do another one. I think we're getting the hang of it. So here, maybe we could do this one a little bit faster. Let's see, we have a tetramethyl dodecane. So the main root here is the dodecane. Do for 2, dec for 10. This is a 12 carbon chain. It's not in a cycle, so let me just draw it out. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so we can just number them arbitrarily, just because I could have drawn this any which way. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's the dodecane, all single bonds. And then we have a 3,6,9,9 tetramethyl. And all this is telling us, remember, meth is 1 carbon. So all this is telling us is that the 3, the 6, the 9, so at the 3, the 6, and twice at the 9 spot, we have methyl groups. And we have 4 methyl groups. That's all the tetramethyl is saying. So it's a little bit redundant. We know we have 4 of them here, 6, 3, 6, 9, 9. We have methyl groups at each of those places. So we have 1 methyl group at 3, and then that is bonded with the 3rd carbon on the dodecane chain. We have 1 at 6, bonded to the 6th carbon on the dodecane chain. And then we have 2 at 9. So we have 1, that's 1 at 9, and then we have another 1 at 9, bonded to the 9 carbon on the dodecane chain. And we're done. That's it. That's 3,6,9,9 tetramethyl dodecane. Let's do another one. 1,3-bis 1,1-dimethyl ethyl cyclopentane. So once again, just take kind of, breathe slowly. It's very daunting right when you look at it, but just start with kind of the core. Cyclopentane. That's just a simple 5-carbon ring. 5-carbon ring. Looks like a pentagon. 1, 2, 3. Let me draw a little bit better. 3, 4, 5. Let me draw that. 5. There you go. That is a 5-carbon ring, and we can number it however we want. So 1, 2, 3, 4, and 5. And this is telling us that the 1 and the 3 position, so at the 1 and 3 position, we have, and the bis is kind of redundant. This is saying we have 2 of these things. So obviously we have 2. We have 1 at the 1, 1 at the 3. So you can kind of ignore the bis. That's just the convention, and we've seen that multiple times. But at each of those positions, we have a 1,1-dimethyl ethyl. So what's a dimethyl ethyl look like? So let's think about it a little bit. Let's think about it. Let me do it in orange. So they obviously named it using systematic naming. And what we have here, we have an ethyl is kind of the core of this side chain. So if an ethyl is equal to 2 carbons, so this is 2 carbons right there. So let me draw a 2-carbon, 1, 2. That is 2 carbons right over there. I'm just drawing it at the 3 spot. I'll draw it also at the 1 spot, actually. So that is 2 carbons right there. That's the ethyl part. And then on 1, 1, so if we number them, we number where it's connected. So it's 1, 2, 1, 2. This is saying 1, 1 dimethyl. So on this ethyl chain, you have 2 methyls. Remember, methyl is equal to 1. So this is 1 carbon. You have 1 carbon. That's what methyl is. But you have 2 of them. You have dimethyl. You have it twice at the 1 spot. So you have 1 methyl here, and then you have another methyl there. Same thing over here. You have 1 methyl on the 1 spot, and then you have another 1 methyl on the 1 spot. And then you are connected at positions 1 and positions 3. So you're connected there, and you are connected right over there. And you're done. That's it. That is our structure. Now, if you did this with common naming, instead of this group being a 1,1-dimethyl ethyl, you might see that, okay, we're connected to a group that has 1, 2, 3, 4 carbons in it. The carbon that we're connected to branches off to 3 other carbons. It is a tert-butyl. So you could also call this a 1,3. Let me just write it down. So another name for this would be 1,3, 1,3 tert, or sometimes people just write a T there. T-butyl, T-butyl, cyclo, oh, actually I should say di-T-butyl, because we have 2 of them. 1,3-di-T-butyl cyclopentane. cyclopentane. So that would be